This short how-to video revisits percentage error calculations that you're likely to encounter in A-level coursework. There are two pieces of equipment that I want to look at in a little bit more detail, and the first of these is measuring cylinders. So on the screen we have a typical measuring cylinder, and somewhere in the question, if you are looking at percentage error calculations, it will give you the accuracy of the measuring cylinder, and it can vary. In this case I've illustrated an accuracy of 0.5 centimeters cubed. I've also labelled a volume on the measuring cylinder. So I want us to imagine that we've used this measuring cylinder to add 64 centimeters cubed of liquid to an experiment. To work out the percentage error, all we need to do is to divide the accuracy by the amount that we've actually added from the measuring cylinder and express that as a percentage. And we do that in a calculation which looks like this. I've taken the accuracy of the measuring cylinder, I have divided it by the volume of liquid that I've added to the experiment, okay, 64, and to express that as a percentage I multiplied it by 100. So the percentage error caused, the percentage error by using this measuring cylinder is plus or minus 0.78%. Now let's look at a thermometer, and again the same rules apply. Here's our thermometer, and it has an accuracy of plus or minus 0.2 degrees centigrade. This would be given in the exam question, or in the rubric which accompanies the practical. So there's a bit of a trick to this one, because often when you use a thermometer you actually read the temperature twice. You take the starting temperature, and in this case I've saying that it's 23 degrees centigrade, but that could be something that you were either given or you measured for yourself. And then we've got the final temperature, the maximum temperature that happens in that experiment, and let's say that's 86 degrees centigrade. Again, this could be a figure that you're actually given as a theoretical value, or a value which you've actually measured in doing the practical. So what is the percentage error of the thermometer? In other words, what is the error that we get by using the thermometer from starting temperature 23 degrees centigrade to a final temperature of 86 degrees centigrade? So here's the calculation. So you can see there is a slight trick to this. We're reading the thermometer twice, so the potential for us to have an error of 0.2 degrees centigrade occurs once here at the start, and it occurs again here at the final temperature. So the percentage, or the accuracy, is doubled because we're reading the piece of equipment twice, and the temperature that we're using is the difference between these two numbers. So we started at 23, we finished at 86, so the difference in temperature between those two readings is 63 degrees. So what we need to do is to express 0.4 divided by 63 as a percentage, so we multiply it by 100, and we find that the thermometer creates a percentage error in the experiment of 0.63%. So then the final question, often given: what causes the biggest experimental error in the particular experiment you're doing? And if we just consider the two pieces of equipment which I've illustrated in this how-to video, well, the answer is simple. In this hypothetical experiment using a measuring cylinder and a thermometer, the biggest percentage error will be caused by using the measuring cylinder. Now I hope that helps. Often you get questions which compare two measuring cylinders, a 100 centimetre cube measuring cylinder and a 25 centimetre cube measuring cylinder, and they ask you to contrast the difference between the accuracy of the big measuring cylinder and the accuracy with the small measuring cylinder. And it works in exactly the same way as we've done here. You work out the percentage error with the big measuring cylinder first and the percentage error with the small measuring cylinder, and then compare the two. Thanks.